Hi, my name is Sana Mathani, and I'm a program manager at Microsoft on the Visual C++ team. For over a year now, the C++ team has been working on building on what is now known as a C++ REST SDK. This presentation will serve to be an introduction to the REST SDK. We will go over the features that are currently in the SDK. We will walk through some examples and discuss what we have planned for the future. Developers are moving away from running their applications locally on machines. Connected, non-blocking, and asynchronous applications are becoming more and more ubiquitous. However, we quickly realized that C++ developers were at a disadvantage. Historically, we've lacked such simple tools for developers using C++. While there are multiple relevant native networking APIs, such as WinINet or WinHTTP, these are not optimized from a productivity perspective for consuming and implementing RESTful cloud services. They don't compose particularly well with standard C++ libraries, and they don't take advantage of modern C++ language features and practices. And thus, the C++ REST SDK was born. It started off as an incubation project on Microsoft's Dev Labs under the codename Casablanca. We have now moved out of the incubation stage and are hosted as an open source library on Codeplex. Now you may be thinking, why would a developer choose C++ for creating connected applications? C++ and the cloud isn't usually what leaps out to developers when they are considering which programming language to use. We think, however, with the right tools and libraries available, C++ will be a strong contender, if not the first choice, when people are wanting to develop high-performance applications. C++ gives developers better latency and throughput. Additionally, developers want to target more than just one platform or operating system in order to maximize their profits and grow their user base. It is at its core that C++ is not tied to any particular platform. Lastly, C++ is also very compatible with existing software. C or C++ often forms the core of other technologies. That being said, we decided to build this library by encompassing the benefits of C++ within a few design principles. One of these was that this library needs to be modern. The power of modern C++ needs to be exploited by placing the power in the hands of developers and thereby increasing their productivity. What does exploiting modern C++ 11 mean? It means using standard template library classes for your collections. It means using shared pointers. It means using lambdas. Modern means clean, safe, and fast. Next, the library must be cross-platform. And cross-platform does not only mean across various operating systems, but also across devices. Lastly, we need a library that provides a simple and straightforward way of building responsive clients and scalable services. Here is a visualization of what currently exists and what we're planning on building for the C++ REST SDK. At the bottom, we have some platform components, Windows and Linux, but there is potential for contributions from the open source community to support other platforms as well. On top of that, there are some APIs that we rely on that already exist. For example, WinHTTP for the HTTP communication underneath our surface area. PPL gives us the composition model for all of the asynchronous long latency operations. I/O completion ports and HTTP sys for the service side are used for listening to HTTP requests or other components. This bottom layer gives us the cross-platform capabilities. Anything you build on top of this layer will also inherently be cross-platform. The next layer is our basic communication libraries. We are building them on the principle that they need to be cross-platform. They need to work the same way across all supported operating systems. They need to do basic HTTP communication. Not all of these are available currently. However, this is what we are planning on putting together. On top of communication, we need serialization. We are currently focusing on JSON serialization. We want to put together a simple JSON library to use with the C++ REST SDK. XML is important too. However, there are already lots of good XML libraries available. Next, in addition to HTTP communication, services often need to access data. We have developed asynchronous streams and file I/O libraries that compose well with the networking APIs. These are built using PPL tasks, which we will discuss later. Next, we imagine that within this framework, developers can build further libraries. Things like Azure Storage and Azure Mobile Services are higher order libraries that are built on top of the C++ REST SDK. These libraries can take advantage of being cross-platform without any additional work. Please note that these libraries are not part of the C++ REST SDK, but just serve as an example on how other developers can take advantage of this toolset. In the most recent release of the C++ REST SDK on Coplex, developers have the ability to create a connection to a server via an HTTP client, send requests, and handle responses. There is also support for construction and use of uniform resource identifiers, as well as constructing, parsing, and serializing JSON values. Additionally, there is support for asynchronously reading and writing bytes to and from an underlying medium via streams and stream buffers. The C++ REST SDK demonstrates how a modern C++ library can be built using composable PPL tasks. Whether you are writing an application that is compute-intensive or is I/O-driven, resource allocation will be essential for scalability. Developing responsive clients and scalable server applications requires asynchrony throughout, which is the focus of this SDK. The C++ REST SDK takes advantage of modern C++11 and PPL tasks throughout its APIs to make dealing with asynchronous operations easy and straightforward. The way asynchrony is represented in the C++ REST SDK is through PPL tasks. Tasks are placeholders for data that will eventually be available. In this case, for example, we can imagine an operation that takes a long time to complete and produces an integer at the end. We have a task of int as a result of this function. This task will eventually be filled in with the result, but the function can possibly return without filling it in. Threads are very expensive objects, and therefore we can give up the thread while we are waiting for this operation to complete. We can continue to execute our program without this function necessarily finishing. Next, what we can do is attach a continuation, which is just a handler which is expressed as a C++11 lambda. This inline function is invoked when the operation finishes and the task is filled in. This is all you need to know about PPL and tasks for the examples in this presentation. To learn more about the parallel programming library, visit this link. We think REST is a very interesting aspect of distributed computing and cloud interactions because it is simple and it's ubiquitous. There are a lot of REST services providing a lot of value, which C++ developers can take advantage of. It is supported in many language environments, and we want to make it easy to use in C++. Let's dive deeper into REST and look at an example of an HTTP client making a request to a REST service. An important concept in REST is the existence of resources represented with global identifiers such as a URI. The first step is to create an instance of an HTTP client which represents the connection to the server. REST services define the set of HTTP operation it supports using HTTP methods. In this example, we are using a GET request to retrieve content from the service. Other possible operations that could be supported by the service are put, post, or delete. Next, using the client instance, we can make an asynchronous GET request to the service. This method returns the HTTP response wrapped in a PPL task. We can attach a continuation to inspect the HTTP response once the request is completed. Some operations that we can perform on an HTTP response include checking the status code, extracting the body of the response to a stream, or parsing the body to a JSON object. A very important aspect of this SDK and REST programming in general is JSON, which is short for JavaScript Object Notation. It has become the lingua franca for simple web services, preferred over XML because of its simplicity and compactness. It is a strict subset of the JavaScript object literal syntax, and therefore it is dynamically typed. Creating a JSON object using the C++ REST SDK is straightforward and simple. A JSON object is essentially a collection of name-value pairs, which we can explicitly build as shown in this example. Once the object has been created, it can be operated on like a collection of tuples. JSON objects are a human-readable, lightweight way of representing and exchanging data that is easy to parse and generate. In REST programming, JSON objects are often serialized and sent over an HTTP POST request, or they can be parsed from the body of an HTTP response. Now that you have a basic introduction of what's currently in the REST SDK, you might be wondering what's next. The team will continue to develop the C++ REST SDK. We will fix bugs and add features to the existing client-side libraries. As well, we are beginning our planning and development for server-side libraries. That being said, we would love to hear from all of you, our customers, about how you feel about our current features and what you would like to see in upcoming releases. We are a small team here at Microsoft, so we want to take advantage of the open source community to help us spread the word. Please visit us on Codeplex and take the REST SDK for a spin. Thank you all for your time, and we look forward to hearing from you soon.